Okay, we're starting chapter 4 today, and we're going to be solving equations in this chapter. So by the end of today's lesson, you should be able to follow the steps required to solve simple equations. So an equation is just a mathematical statement that relates two expressions and says they're equal. So a mathematical statement that says, we'll just use the terminology here, that says two expressions are equal. So you know that there's a difference between an equation and an expression. We've been dealing a lot with expressions in chapter 3. So an example of that would have been to simplify an expression by gathering our like terms. So something like this. I could have given you, and you would have had to simplify that expression down to 2x squared plus 3x plus 2. That's an expression. There's no equal sign technically. Okay? That's an expression, no equal sign. I put the equal sign only because I'm saying that this one equals this one. For an equation, it's different. We've got something like this, 2x equals 4. This is a mathematical statement that relates two expressions. These are two simple expressions, obviously, 2x and 4, but they are nonetheless expressions. Okay, and then there's always an equal sign for an equation. All right. So, a solution is just the value of the variable that makes the equation true. Okay, so think about the one that I've just given you up there, 2x equals 4. There is a value, and I'm sure you all know what it is, 2 for x, that will make the left side equal the right side, right? So if I put in x equals 2, 2 times 2 is 4. So to solve an equation means to isolate the variable. And when you're isolating a variable in an equation, you move terms over the equal signs by using opposite operations. So or inverse operations. Let's just put opposite / inverse. Oopsie, that's an S. All right, so let's talk about that. So inverse operations in math, if you have addition, then the inverse of that is subtraction. If you have subtraction, the inverse of that is addition. If you have multiplication, the inverse of multiplication is division, and if you have division, the inverse of division is multiplication. So if I'm asking you to solve, what I'm asking you to do is figure out what's happening to the x, and then do the opposite of it to get x by itself. So if we look at this one, we have 3 being added to x. If I want to get x by itself, I have to do the opposite of adding 3 to it. I have to subtract 3 from it. So I'm going to, in the first line, I'll just change colors just so you see it better. I'm going to subtract the 3, but I can't just subtract 3 on the left side. That's not right, because technically then I've changed the balance of the equation. And remember, our equations need to be balanced. So we would subtract 3 on this side. So the old rule in math is what you do to one side, you must do to the other. And you do that because it has to stay in balance. So x plus 3 minus 3 equals 10 minus 3, and then I would just evaluate both sides. So this, of course, should work out to just x if I pick the right number to subtract, and then I get 7 over here, and I've isolated the variable. If I want to check, what I would do is I would take my answer of x equals 7, and I would start with my original equation, x plus 3 equals 10. And now I'm just going to substitute in 7. So I'm just going to write 7 plus 3 equals 10. And then I work just the columns downwards. So 7 plus 3 is obviously 10. This is obviously 10. So left side equals right side. So I know my answer is right. Okay, so let's ask ourselves, what's happening to the m in this situation? The m is being multiplied this time by 2. So what's the inverse of multiplication? Division. So we are going to divide both sides by 2. Remember, what you do to one side, you must do to the other. And when I do that, 2 over 2 is the same as 1, right? 1m. Well, we don't write the 1. We just write m. And then 16 divided by 2 is 8. And again, we're going to check. So we're going to start with the original equation. I'm going to sub in my 8 wherever there's an m. And this time it was multiplication, right? So that equals 16. 16 equals 16. Left side equals right side. So I know again that I've got the right answer. All right. Easy peasy, right, guys? All right. You guys, go ahead, please, and solve these two for the indicated variable. Pause the video and then check to see if you've got it right. Okay, so x plus 4. And then I'm going to subtract off 4 on both sides. So I subtract the 4 off both sides, and then I end up with 4 minus 4 is just 0, of course, but 9 minus 4 is 5, so I get x equals 5. In doing my check, I rewrite the original equation, and then I sub in my answer. So 5 plus 4 equals 9, and then 9 equals 9, and left side equals right side. Done. Okie dokie. Now, common mistake for this one would be that students would divide through by the number 9 on both sides, but really, what is p being multiplied by here? It's really being multiplied by minus 9. So I am going to divide by minus 9 on both sides. And when I do that, this should just cancel because negative 9 divided by negative 9 is positive 1. Positive 1 times p is just p. And then 81 divided by negative 9 is negative 9. Let's just check. So I started with negative 9p equals 81. And I have negative 9 to substitute in for p. And negative 9 times negative 9 is 81. And left side equals right side. Alrighty. Hopefully you got both of those. Oh, there's more. Oops. So go ahead and pause the video again, please, if you haven't already done these. And go ahead and do them. And then I'll come back in a sec. Okay, so you can see that the x is being multiplied by a fraction here. Don't freak out. It's just a fraction. You treat it like it's any other number. Okay? Treat it like it's a whole number. So what did we do with the negative 9 in the previous one? We divided everything through by, whoopsie, I'm going to confuse you here. Not by negative 1. Divide through by 1/3. Okay, so I've got 1/3 here that I'm dividing both sides by. So 1/3 divided by 1/3, well, that's something divided by itself. That gives you that 1, which just leaves you with the x. Now, negative 3 divided by 1/3. You can do that with your calculator. You can also just do this if you want. Negative 3 times 3 over 1 when you flip the fraction and multiply. So this is going to be x equals negative 9. I would prefer, I've showed it like this, but I really would prefer that you show it with a bracket instead of the times. But nonetheless, it's multiplication here because you've divided, and then to divide a fraction, you flip it and multiply. So x equals negative 9. Let's check that one because that one was tricky. So we've got 1/3 x equals -3. And if x is -9, we're going to multiply this. And if I'm working the left side independently here, I see that 1/3 times -9 is the same as if I'm multiplying tops by tops and bottoms by bottoms, which is what I do for multiplying fractions. 1 times -9 is -9, and 3 times 1 is 3. So I get -9/3 equals -3, and -9/3 is -3. There we go. Ta-da, we got it. Okay. So this one, the m is being reduced by 3/4, and so we're subtracting here, and the opposite operation of subtraction was addition. So in order to get m by itself, we add 3/4 to both sides. So I am going to just show it as 3/4 plus 1/4 equals m minus 3/4 plus 3/4. Are we okay with that? So I'm adding 3/4 to both sides. 3/4 plus 1/4, the common denominator is 4. I can add the tops then and keep the bottom the same, and that becomes 4/4. And when I subtract that, that becomes just m. And so I end up with m equals 1. I'm going to check that by substituting back into my original equation, and I would get 1/4 equals m minus 3/4, and then m is 1, so 1 minus 3/4. Now, if I'm doing this in my head without a fraction or without a calculator, I am going to turn that 1 into a fraction with a denominator of 4, so that's going to be 4/4 minus 3/4, right? And 4/4 minus 3/4 is 1/4. So I know that left side equals right side, and I am correct. M does equal 1. All right, we're cooking here. Now we're going to get a little more complex, because we're going to have to solve equations that involve more than one step. So we either added or subtracted or multiplied or divided to isolate our term. But this time, what we might have to do is combine some like terms, okay? So you isolate the term with the variable, and you isolate the variable itself if you can. So 5x plus 2 equals 17. So the term with the variable is 5x, obviously. And I want to get the 5x by itself first. That's what this means. So what is being added to the 5x? 2, obviously. So I am going to subtract 2 from the 5x. And I'm going to do that on both sides, of course, because you know the rule. What you do to one side, you must do to the other. So there we go. Now, I end up with 5x on this side because 2 minus 2 is 0. That's what I wanted. And that's equal to, of course, 15. And now I'm left with just one step where I can isolate the variable that is associated with the x, right? Like I can isolate it by dividing, in this case, the opposite operation of the multiplication. So I'm going to divide by 5 on both sides, and I'm going to end up with x equals 3. And it does say check, so I better do that, so I'll do it over here. So check. Rewrite the original equation. Substitute in what you got. Don't move anything around. Just work the columns independently. So 5 times 3 is 15 plus 2. That's 17 equals 17. And left side equals right side. So we are good. All right. Let's try this one over here. 8 minus 2b equals 11. This one's tricky. So remember, I want to isolate the term with the variable. So the term with the variable has a sign here. So this is minus 2b. What's really happening to the minus 2b on this side? We're adding 8 I know that it looks like subtraction here, but really when you want to isolate the variable, you have to keep the sign in front. And so this is like 8 plus negative 2b. Okay, so we are adding 8 to the negative 2b. So we need to subtract the 8 on both sides. So this is going to be 8 minus 2b. And I'll put the minus 8 here, just equals 11, and then minus 8 again. So I'm getting rid of the positive 8 on this side by subtracting by 8. Okay? I know that one might be a little tricky. So 8 minus 8 is 0, and I'm left with minus 2b. And over here I'm left with 3. And now it's just a matter of getting rid of that negative 2 that's being multiplied by the b. Inverse operation of multiplication is division. So of course I'm going to divide by negative 2 on both sides. So this is b equals negative 3 halves. And if I check this one's trickier because the answer was a fraction. So when I divided through by negative 2, there are a couple things. Remember, we don't keep the negative in the bottom of a fraction, so I moved it up sort of in front of the fraction, or you could put it in the numerator. And you just have to be very, very careful about that, okay? That you've divided through by the negative 2b, because the coefficient of the b was negative. So when we check now, we go back to our original. 8 minus 2b equals 11, and the b is negative 3 halves, so it's going to be minus 2 times our b, which is negative 3 halves. Oops, I forgot to use red. Oh well. Oh no, I haven't been doing that. Equals 11. All right, tricky, but minus 2 times minus 3 halves. Well, a minus times a minus is a plus, and our multiplication of fractions, tops by tops, bottoms by bottoms, but there's a minus here. So this is positive 6. Oopsie, let's use the red. This is going to be positive 6 over 2, right? 6 up here, 2 on the bottom, equals 11. Does this work out? Does left side equal right side? Let's see, 8. 6 divided by 2 is 3. Equals 11, and 11 equals 11, and left side does equal right side. So a big takeaway here, guys, is that you are not reducing this down into a decimal. Okay, you're leaving your answer as a fraction. You're putting the minus sign either out in front or in the numerator. Okay, pause the video and try the next one, please. Okay, so we're going to isolate the 7x first by adding 5 to both sides. That will remove the minus 5. Okay, and then this leaves me with 7x on this side and 21 on this side. And of course, when I try and undo the operation that has been done to the x, that's multiplication of 7. We're going to divide by 7 on both sides, and we end up with x equals 3. And when I check that one, 7x minus 5 equals 16. 7 times 3 minus 5 equals 16. 21 minus 5 equals 16, and 21 minus 5 is 16, luckily. So we do have left side equals right side. If it didn't come out to left side equals right side, if this doesn't work out to the same thing as this, then you know you've got the wrong answer. You've made a little boo-boo in there somewhere, and you need to go back and look through the body of your work or look at your check. Maybe you made a mistake there. Okay? All right. Okay, we've got a couple of tricky ones here. You can see that we've got x minus 5, and the whole thing, the whole binomial here is being divided by 2. Okay? So, in order to get this one so that we can isolate the x, we have to deal with the 2 on the bottom first. And so This whole thing is being divided by 2, so the opposite operation of that would be multiplication by 2. So I am going to multiply the whole left side by 2. And what I do to one side, you know I have to do to the other. Okay? And then, what you want to think about here, which is tricky, is I could distribute, there's a couple of ways I can do this. I can distribute the 2 in. So I would end up with 2x minus 10 over 2 equals 12. I don't know why I just did that all in red, but anyway. And then you could take this and say, okay, well, the 2 is being divided into both terms of that binomial. So I could rewrite this as 2x over 2 minus 10 over 2 equals 12. 2x divided by 2 is just x. 2 divided by 2 is 1, remember. Minus 10 over 2 is 5. And this is equal to 12. And now you know how to isolate your variable. You can see that subtraction by 5 is happening, so we need to add 5. So we're going to have x minus 5. I switched colors here on you. Plus 5 on both sides. So I'm adding that 5 to both sides, and that's going to result in me isolating the x and getting 17. I will check this one because it's so difficult. So that now we have x minus 5 over 2 equals 6. I'm going to substitute the 17 in there. This is 17 minus 5 all over 2. So be really careful. When you see that line, it's covering everything on top. That means you have to do the top first. So 17 divided by 5 is, 17 minus 5 is 12 over 2, which equals theoretically 6. 12 divided by 2 is 6, so 6 equals 6, and left side equals right side. And so we know we're good. Okay, for this last one, we've got something that we've got brackets that we need to get rid of. Okay, so I think the very first place that we would start here would be to distribute that 4. I'll just rewrite the question. So distribute that 4 into the brackets. So this is going to become 4x minus 12 equals 15. And then we want to isolate the 4x, so we're going to add 12 to both sides, because right now there's a 12 that's being subtracted, and we have to do the inverse operation. So here we go. 4x minus 12 plus 12 equals 15 plus 12. All right, so then we're going to end up with 4x equals 27, and the x is being multiplied now by 4, so the opposite operation of that is dividing by 4. All right, so we end up with x equals, and this is not divisible, so we would leave it as a reduced fraction, and there's nothing that goes into 27 and 4. So we're going to leave it as the fraction 27 over 4. So obviously, you know, on a test, red flags because you're ending up with a fraction, but there's no reason you can't end up with a fraction. So, but this would definitely be one on a test that I would check, even if I wasn't being asked to. So let's try it. So check. So we start with the original equation, and we substitute our value for x in. And then remember, BEDMAS says do the brackets first. So before we distribute the 4 through, or if these are just like terms, which they are, they're just numbers, we're going to simplify that. So this is really like, let me just do the, if I wanted to get 3 and have a common denominator of 4, that would really become minus 12 over 4. I'm going to multiply the top by 4 and the bottom by 4, right? This is like over 1, so times 4 and 4. And so this is 12 over 4, which is of course 3. And 15. So I haven't done anything to both sides. I've just rewritten a 3 as an equivalent fraction. Okay, so 4 times, well, we've got a common denominator, so we have 15 over 4 when I subtract these two. And then, of course, when I'm multiplying, I could go through the motions of multiplying 4 over 1 and multiply the tops by the tops and the bottoms by the bottoms. And when I do that, I would get 60 over 4 equals 15. And when I divide 60 over 4, by 4, I would get 15 equals 15. And that's all perfectly fine. I could do that. The other thing that I could do at this point is I can see that this 4 is going to be ultimately able to be canceled with this 4, right? If I have 4 over 1 times 15 over 4, then really, because of the laws of multiplying numbers, it doesn't matter whether you multiply the 4 times the 15 or the 15 times the 4, you're going to get the same number. So I could actually theoretically reverse this and write it like this, right? Where I switch the 4 and the 1 on the bottom, and then 4 over 4 is just 1. It just cancels to 1. So really all I'm left with is 1 times 15, which is 15. So I can just cancel these 4's, in other words, and I would be left with 15 equals 15. If we go back now to say here, I couldn't just cancel the 4's here because I've got something else that the 4 has to multiply. Okay, so you have to be careful when you do these things. Yes, here because there's only one term being multiplied by the 4, but here because there were 2 terms, I could not just cancel these 4's. Okay, so be careful when you cancel. Just make sure you're doing it at the appropriate spot. To end off, we just have a quick little word problem. Not too difficult. So, a dance studio director is given $3,025 to buy recital costumes for the Saturday morning pre-ballet classes. If each costume costs approximately $40, how many students can she outfit? So, it says to write an equation that models the number of costumes she can buy. So, what we need for an equation is a variable, because an equation always has a variable in it, right? We're solving for something. So, in this case, you would go to the question mark in the question to determine really what are you trying to find. So if you look here, whoops, you can see it says how many students can she outfit. So we are going to let X represent, and sometimes you use a more appropriate letter, but let's just use X here. Let X represent the number of students she can outfit. Okay, now that we have our variable, and this is the way I want you to always present your let statements. You're going to use the word let. You're using all words except for that little variable there. You're not putting let X equal. You're using the word represent. Okay, it's a statement. It's a sentence. Okay, let's come up with an equation involving X that involves the information from the question. So I know that if each costume costs $40 and she has X number of students that she's outfitting, then 40 times X is going to represent, the total cost that she's going to spend on the outfits. So 40X equals $3,025. All right, now it says solve the equation and write a conclusion to the problem. All right, I'm just going to rewrite it. And you know that to solve this equation would require us to do the opposite operation on the X. It's multiplication, so we're going to undo that by doing division of that coefficient. Now, as I recall, X is going to equal 75.625. So, the question now becomes, do I round the 75 up to 76? Normally, if we were were required to round to the nearest whole number, we would be looking at the number after the decimal If it's 5 or greater, we would round the whole number up. And if it were less than 5, we would just get rid of the decimal and leave the whole number as is. But in this case, we are trying to figure out how many costumes we can buy for $3,025. We don't have any more money. So we can't buy 0.625 of a costume, therefore we must round down. And I'm going to write a conclusion. I'm going to write my therefore. Therefore, the director can outfit, if you will, 75 students. Okay, that's all for today.